Hi everybody, it's Mr. Russo. This is my second lesson on Pythagorean theorem. I'm going to be removing the other lesson. Okay, so this is going to be a little bit nicer. I think that there's a little bit less adjusting of the camera this way. So the Pythagorean theorem is all about this equation. It has to only do with right triangles. So if I were to point to the right angle, it means that there's a 90-degree angle in the triangle. So this is only going to work for triangles that are right or that have a 90-degree angle. And what is special about this theorem or equation is that they're saying that when you have a right triangle, if you take the area of, or if you were to square this side and square this side, and these sides, by the way, are called the legs of the triangle, or the smaller sides of the triangle, the largest side is always going to be across from the 90-degree angle, and they always call that side C. So side A and B are both the smaller sides, they call them the legs, and side C is called the hypotenuse, the longest side, or the side across from the 90-degree angle. So what they're trying to say is, they're saying that if you were to square side A and square side B, and then add these two values together, it's going to equal whatever side C is squared. And that's where that equation comes from. So they're saying if you were to make this side into a square, where you have this side is equal to this side, equal to this side, you create this square. And then if you were to create this square, if you were to add these two squares together, it's going to equal the amount of area that this square has. That's what this little picture is about. So if you take the area of the blue square, area of the red, it's going to equal the area of the yellow square. Okay, so enough of a little bit of a picture as to what the equation, Pythagorean theorem, is about. All right, let's actually start using it. Okay, so if you're going to solve for an unknown side, let's focus in a little bit more on the first example. Okay, so example number 1, we're going to first write down the theorem, or the equation. A squared plus b squared equals c squared. And if I'm going to try and solve for this unknown side, I have to acknowledge that this is the side that's across from the 90-degree angle. And the side across from the 90-degree angle is always going to be side C. So I do not know side C. So that means that these two sides are A and B. So I have to take those values and substitute them in. Usually the smallest side is side A, but it really doesn't matter too much. For A and B, it doesn't really matter where you put them. It only matters if you are looking for side C, that you make sure that you leave side C as the unknown. So 5 squared plus 12 squared equals c squared, and you just keep working through all the intermediate steps. You can use a calculator, or if you're just good enough, you can just avoid using the calculator. So 25 plus 144 equals c squared. You're going to add these two since they're on the same side. 169 equals c squared. And now here comes the one step that you need to learn. In order to get c alone and not have c squared, you do the opposite of squaring, which is called taking the square root. And what you do to one side, you must do to the other side. So you take the square root of both sides. So the square root of anything squared, those two operations cancel each other out, and you're left with just c. And if you use the calculator, the graphing calculator, if I hit second function and then my x squared button, it goes to the yellow function, which is the square root, and then I type in 169. I hit enter, and it gives me 13. So now I know that it's exactly 13. Sometimes you're going to have to approximate or round to the nearest tenth, but in this case, all the numbers worked out to be integers. So I know now that 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 largest side is 13 units long. And just a little bit of a geometry fact, the addition of the two small sides must be larger than the largest side. That's a separate geometric fact other than the Pythagorean theorem. Okay, number 2. Now we look at this one, and across from the 90-degree angle we already know C, so we're not looking for C. So when I start writing my theorem and I substitute in, I already know C, and the 8 can either be A or B. So let's say we'll just make it A. A squared plus B squared equals 17 squared. And then A squared, or 8 squared, is going to be 64, plus B squared equals, and if you're having trouble, use the graphing calculator, 17 squared, you type in 17, you hit the x squared button, hit enter, it gives you 289. And then you subtract 64, and you get b squared equals 225, and then you take the square root of both sides again. Oops, I'm a little bit off. And we get b is exactly equal to, if we use the graphing calculator, take the square root, we get exactly 15. So we now know that this is 15, and we look at our geometric fact again. The addition of the two smaller sides is greater than the largest side, so it works out. Geometrically, everything works out. Okay, let's go to our next topic. Alright, do the three sides given form a right triangle? So now we have all three sides, and we're just testing, using the Pythagorean theorem, if these three sides form a right triangle. They'll most likely form a triangle, but not maybe specifically a right triangle. So if we look at only number 1 right now, I know that this does form a triangle, because the addition of the two smaller sides is greater than the largest side. So it forms a triangle, but we don't know if it's specifically a right triangle. So I know that that's going to be my C if it does form a right triangle, because it's the largest side. So I test it using the theorem. I plug in my largest side first to make sure I'm doing it right, and the other two are interchangeable. I'm going to use a lot of my graphing calculator now. So off to the side a little bit, hit clear. I do 20 squared, I get 400. And then I do 21 squared, I get 441. I do 29 squared, 841. I add 400 and 441, I get 841. Is that equal to 841? So because it is exactly equal on both sides, that means that it worked out where when I square this value and I square this value and I add them together, yes, it is true that it does equal exactly this. Well, that's what the whole theorem is about, that it's only going to work for right triangles. So we're going to say, because we got a true statement, we're going to say yes, it is a RT, right, and then a symbol triangle. Yes, these three sides form a right triangle. Alright, let's try number 2. If we test number 2, a squared plus b squared equals c squared. 12, 30, and 35. So we're going to run through this a little bit quicker. This we get 144, this we get 900, and what do we get when we get 35 squared? Use my calculator. 35 squared, we get 1,225. Now if I were to add these two together, I'm going to get 1,044, and that does not equal 1,225. So now what's going to happen is, this is not a true statement, this is false, and we're just going to simply write that no, it is not a right triangle. Okay, let's try and do one word problem. If a cat is caught in a tree and it's scared to climb down, you grab your 30-foot long ladder and place it about 7.5 feet from the base of the tree so it reaches the cat exactly. Determine how high up in the tree the cat is using the Pythagorean theorem. So 30-foot ladder, 7.5 feet away from the base of the tree. So here's my silly picture. And I'll have to zoom out a little bit further. Alright, so here is you, here are you, and here is the cat. And this is 30 feet long. And you are 7.5 feet away from the base. And you're trying to determine what this height is. So this is a question mark. So from here, what I'm going to do is I'm going to draw a little right triangle, where I know my hypotenuse, my longest side, I know one of my legs, and I don't know this height. So over here, I'm going to show all my work. So a squared plus b squared equals c squared. I know my c value, which is 30. I know one of my other sides. So I do on my graphing calculator, 7.5 squared. 7.5 squared. I get 56.25 plus b squared equals 900. From there, I'm going to subtract 56.25 from both sides, and I get b squared equals minus 56.25 on my graphing calculator. 900 minus 56.25. I'm going to get 843.75, and now I got to take the square root of that. So what's the square root of 843.75? Whoops, I'm a little bit off. So second function, square root of 843.75, and I get about, see, this is what my graphing calculator gives me, about 29.04. So I'm going to say about, approximately 29 feet. So it's really, really close to the height of the ladder itself, all right, or the length of the ladder itself, but you're really only 29 feet high. That's how high the cat is, 29 feet high. All right, very good.